Hi, I'm Cheryl Leach. In this problem, we're going to be using the limit definition to find the slope of the graph of a function. The function we're going to be looking at is the function f of x equals 2x squared minus 3. And we're going to be looking at it at the point 2, 5. The first thing we need to do is take a look at the slope of the secant line. I always like to write the definition down first. It helps me remember it. So the slope of a secant line, we use what's called the difference quotient. And it's f of x plus delta x minus f of x all over delta x. Now, there are really three parts to this difference quotient. The first part is the f of x plus delta x. The second is the subtraction of f of x. And the last part is the division by delta x. In mathematics, we often work from the inside out, and we're going to do exactly the same thing for this particular problem. Now, before I get going, I should probably mention one other thing, and that is because we're looking for the slope at the point 2, 5, one option is to plug a 2 in for all of the x's. However, I like to keep it general. That way, at the end of my problem, it doesn't matter whether I'm looking for the slope at one point or at a variety of points. I can just plug in the appropriate x values. So we're going to keep this one as general as possible. So step one then, working from the inside out, as I said, is to deal with f of x plus delta x. That's a function evaluation. My function tells me exactly what to do with the input. It says to square the input, multiply by 2, and then subtract 3. In this case, my input is x plus delta x. So I'm going to take x plus delta x, square it, multiply by 2, and subtract 3. The next step is to deal with the subtraction of f of x. Now, I like to make sure that I always put that in parentheses. F of x often has several terms, and we want to make sure that we subtract all of the terms. And that's exactly what's happening in this problem. I have two terms, so I'm going to be subtracting 2x squared minus 3. The last step is the division by delta x. That's probably the easiest step. You simply divide by delta x. At this point, we have quite a bit of algebra to do. So thinking in terms of order of operations, we're going to start with the exponent first, and I'm going to square x plus delta x. So I'll write that as 2 times the quantity x plus delta x times the quantity x plus delta x, because I'm multiplying x plus delta x by itself. I still subtract 3 and subtract the quantity 2x squared minus 3, and divide everything by delta x. Now, in order to do this multiplication, I'm going to need to use FOIL. So FOIL tells me I take my first terms and multiply them together, then my outside terms, that's x delta x, the inside terms, which will again be x delta x, and then my last terms. And again, I'm going to subtract 3 and also the 2x squared minus 3 and have everything divided by delta x. More algebra. The next step is going to be to distribute, or I'm sorry, before I distribute, I'm going to notice that I have two terms here that are exactly the same. So I'm going to combine them. So I'll have 2 times the quantity x squared plus 2x delta x plus delta x squared minus 3 minus the quantity 2x squared minus 3 all over delta x. Now I'm ready for the distribution. I'm going to go ahead and distribute the 2, and while I'm at it, I'm going to distribute the minus across that second set of parentheses as well. So I have 2x squared plus 4x delta x plus 2 delta x squared minus 3, and distributing the negative across, a minus 2x squared plus 3 all over delta x. Now I notice that I have several terms that I can combine. There's a 2x squared and a minus 2x squared, which will add together to be 0. And in a similar way, I have a minus 3 and a plus 3. That leaves me with a 4x delta x plus 2 delta x squared all over delta x. Now I notice in my numerator that there's a delta x in both of those terms, so I can factor it out. And finally, I notice that I have a delta x as a factor of both the numerator and the denominator, so I can cancel those. And that leaves me with 4x plus 2 delta x. Now there's one thing I want to make sure I take care of here, and that is that these two expressions are the same as long as delta x does not equal 0. If delta x equals 0 in my last step, the answer will be 4x. In the step above it, it'll be undefined because I'll be dividing by 0. So when delta x is 0 is the only spot where these two expressions are different. All right, well that is the slope of my secant line, but that's not really what I'm interested in. I want to know what the slope of the graph of the function is. And to find that, I need to take the limit as delta x approaches 0 of my slope of my secant curve, which in this case is 4x plus 2 delta x. Now notice I didn't worry about the delta x not being allowed to equal 0. And that's because I'm taking the limit as delta x approaches 0. Delta x is going to get very, very, very close to 0, but it's never actually going to equal 0. So I don't have that problem where these two expressions are different. So I can just use the 4x plus 2 delta x version. Okay? Now, as delta x approaches 0, what happens to this expression? Well, 4x has nothing to do with delta x, so it remains at 4x. As delta x approaches 0, 2 times delta x goes to 0. So the slope is going to be 4x. Now this is going to be the slope at any point on my curve. I'm interested in what's happening at the point 2, 5. So all I need to do is plug 2 in for the x. And so the slope of my graph of my function at the point 2, 5 is 8. I hope that helped. Thank you.